In this example, we need to find the values of P and Q, and those are two forces on the diagram, so that the system is in equilibrium. Well, we have three forces here: a P force, a Q force, and a 100 force as well. That's all, just three forces. Let's first of all clearly understand what we mean by equilibrium. That means there's no resultant force in any direction. So these forces are completely balanced. So if there was an object at the middle of these three forces, then it would not accelerate in any direction. There is no resultant force. Now, taking a closer look at this diagram, you might see some extra lines and it might look a bit strange. We seem to have a vertical line and then a dotted line which isn't vertical to it, which looks a bit strange. There is actually a reason for that, which I'll go into in a moment. But a natural way to start this would be to introduce a horizontal axis to go with the vertical axis, and then find the horizontal component of every single force. It'll equal 0 because we're looking for equilibrium, and then do the same thing for the vertical, and again it'll equal 0 because it's in equilibrium. That would be fine. That would absolutely work. I'm just going to, however, use this dotted line that has been introduced, and I'm going to draw another dotted line in the same direction as P. Now let's look at the angles a bit in a bit more detail. Let's consider this here. Of course, that's going to be 180 degrees altogether. So the missing bit, the angle between P and this dotted line, is going to be 180, take away the 30, take away the 15, take away the 45, which of course is 90 degrees. So this question mark, which I'm now getting rid of, is actually a right angle. So the dotted line I've introduced in the same direction as P is actually perpendicular to the dotted line already there. And that's why the dotted line was already there. It was to possibly help you or guide you towards realizing that P and the dotted line, they are perpendicular to each other. So in this example, instead of working out horizontal and vertical components, I'm going to do components along the two dotted lines. All that matters is that they are perpendicular to each other, and they will be. So I'm going to resolve, first of all, in the direction of this dotted line along the direction of P. So P points in that direction already, so P's component in that direction is the whole thing, just P. Now I'm going to need to work out a couple more angles here. I'll need to know this angle, which is vertically opposite the other 30-degree angle. So that's 30. And then I'll also need to know how big this one is. Well, since the 100 Newton force is horizontal and we've got this vertical line here, then it'll be 60 degrees. Because the 60 and the 30 together make a right angle. So back to resolving in the direction of P, in P's direction. So P is completely in the direction, so we get the whole of the P force. Now the Q force, I'm going to turn Q through 75 degrees, but then it'll point in the wrong direction, so I need a minus. So it'll be minus Q, and then cosine of the angle you're turning it through. That's the Q component in the direction of this green dotted line. Same for the 100 Newton force. I need to turn the 100 Newton force through 60 degrees, and again it'll be pointing the wrong way, so I need a minus. So it'll be minus 100 cos 60. And I can put all of that equal to 0 because we are looking for when the system is in equilibrium, and that's when there will be no resultant force. So we can definitely put that equal to 0. Let's do the same thing, but now resolving in the direction of the other dotted line. And the advantage of doing this method is now when we resolve in the direction of the other dotted line, the P force will not be included. I'll say that again, the P force will not be included. If you try to include it, you'd be turning it through 90 degrees. It would be P cos 90, but cos 90 is 0, so it will not be included. So in general, if a force is perpendicular to the direction that you're working in, then it will not be included in your equation. So in the direction I'm currently working, only the Q and the 100 forces will be included. So it'll be Q cos 15 degrees. I'm turning the Q force through 15 degrees, and then it points in the same direction that I'm working in, so it'll be positive. And then the 100 Newton force, well, I need to figure out this angle over here. Well, the two dotted lines are perpendicular to each other, so the 60 plus this mystery angle must make a right angle, so that must be 30 as well. So it'll be minus 100 cos 30, because I'm turning the 100 Newton force through 30 degrees, but then it's pointing opposite to my direction, which is why I need the minus. Once again, we're searching for when it's in equilibrium, so there will be no resultant force, so we can put all the components equal to 0. Now, if you've done this question by resolving vertically and horizontally, both of your equations would include P and Q. You just then solve them simultaneously. It's absolutely fine doing it that way. But the way I've done it, my second equation only includes only includes Q. So I'm going to concentrate on the second equation and find Q. So Q cos 15 will equal 100 cos 30. So Q will be 100 cos 30 divided by cos 15, which is 89.7. And remember units, it's a force, so newtons, and show when you've rounded. We're now going to go back and work out P. Please make sure you use the unrounded value here, the one that's possibly still on your calculator screen. I've got 89.65754722, etc. on the screen. I'm going to store that in the calculator's memory and use that to get P. So I'm not going to use the rounded version of Q. I'm going to use the full version from the calculator to get P. So rearranging equation number 1, I just realized I didn't number them, so I'm going to call the first one equation number 1, second one equation number 2. We've just rearranged equation 2 to get Q. Now I'm going to rearrange equation 1 to get P. So it'll be Q cos 75 plus 100 cos 60, and I get 73.2 newtons to 3 sig fig. At the end of a question, always check that you've done everything you needed to do. Find the values of P and Q so that the system is in equilibrium. That's all you need to do, find P and Q, and that's done.